Hi! In this chapter, we'll understand everything we need to know about the weather. The French novelist Marcel Proust states that a change in the weather is sufficient to create the world and oneself anew. Weather and its elements. One chilly winter morning, you wake up feeling cold and instinctively reach for warm, thick clothing to protect yourself. On the other hand, during summer, you prefer light, airy clothes that help you stay cool and at ease. In both cases, you are simply reacting to your body's signals. Your body is detecting the change in weather and guiding your response. What is weather? Weather refers to the condition of the Earth's atmosphere at a specific time and place. But what exactly is the atmosphere? Simply put, it is a blanket of gases that surrounds certain planets. On Earth, we commonly refer to these gases as air. You can imagine the Earth's atmosphere like a multi-layered cake. The layer closest to Earth's surface is known as the troposphere. This is where all land-based life, plants, animals, and humans exists and breathes. It is also the zone where nearly all weather-related events occur, many of which we'll learn about in this chapter. The troposphere reaches up to about 6 to 18 kilometers above ground level. It is thinner near the poles, where colder air contracts, and thicker over the tropics, where warmer air expands. We use many familiar terms to describe the weather, such as hot, cold, rainy, cloudy, humid, snowy, or windy. These words express how we feel and observe the different aspects of the weather around us. The elements of weather are: temperature, refers to how warm or cold the air feels. Precipitation, includes all types of water that fall from the sky. This could be rain, snow, sleet, or hail. Atmospheric pressure, it is the force exerted by the weight of the air above us on the Earth's surface. Wind, it is the flow of air, and we measure it by noting both its speed and the direction it's coming from. Humidity, it describes how much water vapor is present in the air. Since ancient times, people have carefully watched nature and learned to interpret its signs to predict the weather. Whether it was birds flying closer to the ground, ants shifting their eggs, squirrels stockpiling nuts, frogs croaking more than usual, or pine cones opening or closing, each of these behaviors offered important clues about approaching rain or storms. Such knowledge has been passed along through generations. Even today, across many regions of India, traditional methods are still relied upon to anticipate changes in weather, especially the onset of the monsoon. Let's now understand a few terms. Sleet. This is rain that has either completely or partially frozen before reaching the ground. Hail. These are small, solid pellets or balls of ice that fall from the sky, much like rain. Water vapor. This refers to water that exists in its gaseous state rather than as a liquid. Forecast. To forecast means to make a prediction in advance. Here, it refers specifically to predicting the weather. Observing nature's clues. When ants start moving their eggs to higher places, it's often a sign that heavy rain is on its way. In the forests of the Western Ghats, frogs croaking loudly is another sign that rain may be approaching. Pine cones, too, respond to weather changes. These natural structures close up when the air is humid to shield their seeds, and they open when it's dry, helping the seeds spread under suitable conditions. What is meteorology? Meteorology is the scientific study of weather and how it changes. This branch of science forms the foundation for predicting the weather. Over the past few centuries, scientists have developed accurate tools and techniques to track and measure various aspects of weather. Using this data, meteorologists work to forecast what the weather will be like in a certain place, whether hours, days, or even weeks in advance. But they don't just glance at the sky and make guesses. They use some fascinating instruments to help them, and we'll now explore a few of those. Weather instruments. A. Temperature. You've earlier explored various thermometers used to measure temperature, such as the clinical thermometer used for checking body temperature and the laboratory thermometer for experiments. You've also come across temperature scales. Two of the most common ones are the Celsius scale and the Fahrenheit scale. For example, a cool 15 degrees Celsius is equal to 59 degrees Fahrenheit. Thermometers come in many forms. Some are designed to record the ambient air temperature, while others are built to capture the highest and lowest temperatures over a day. Many thermometers work with a colored liquid that expands when heated. Today, digital thermometers are becoming more popular since they provide more accurate readings and can store greater amounts of data. These temperature readings can also be used to calculate certain important statistics. What is the range of temperature? It is the difference between the highest and lowest temperatures recorded over a specific period, typically 24 hours. What is the mean daily temperature? It is the average of the day's maximum and minimum temperatures calculated by adding them and dividing by 2. What is the India Meteorological Department? Established in 1875, the India Meteorological Department, IMD, is the country's primary weather monitoring organization. Its motto, Ditit Jate Vi, meaning from the sun comes rain, is a line from the ancient Indian scripture Manusmriti. The full verse tells us, from the sun comes rain, rain produces food, and food gives rise to living beings. Let's now learn a couple important terms. Ambient. The word ambient refers to something related to the immediate environment or surroundings. Statistics. Statistics is the method used to collect, study, and interpret data. It helps us spot patterns, make sense of events, and even make predictions based on the information gathered. Let's now move on to the second component of weather and study its instruments. B. Precipitation. If the weather report says that a location received 30 millimeters of rainfall in a day, what exactly does that mean? And how is rainfall measured? Rainfall is recorded using a tool called a rain gauge. When it rains, water is funneled into a container where it gets collected in a cylindrical tube. This tube has a scale marked on it that helps measure the depth of the rainwater collected. So, if the water in the container measures 5 millimeters in height, we say the area received 5 millimeters of rainfall. Let's explore. Create your own rain gauge using the design shown in the diagram above. Place it in an open space, far from trees, walls, or anything else that might block the rain. Make sure the rain gauge sits on a level surface and is stable so it doesn't fall over in the wind. Every day, at the same time, note down the amount of rainwater collected using the scale. If it snows, allow the snow to melt before taking your measurement. Do this daily for a whole month. At the end of each week, work out the average rainfall for that week and observe how it changes from week to week. Let's now move on to the third component of weather and study its instruments. C. Atmospheric pressure. We can easily sense changes in temperature or rainfall. But have you ever noticed that the air sometimes feels unusually heavy, especially just before a thunderstorm? That sensation is linked to atmospheric pressure, which refers to the force exerted by the weight of the air all around us. Atmospheric pressure is typically higher at sea level and gradually decreases as you go up into the mountains. When you're climbing to higher altitudes, the air becomes thinner compared to the lower plains. This means less air pressure and, importantly, less oxygen for your lungs to absorb. Since your body receives reduced oxygen, it needs to work harder, which is why people often feel tired, dizzy, or out of breath at high elevations. However, this doesn't mean the pressure is always high at sea level or in the plains. Sometimes, pressure can fall sharply, creating what meteorologists call a depression or a low-pressure system. Such systems can intensify and lead to storms or cyclones. To measure atmospheric pressure, we use a device known as a barometer. Like thermometers, barometers come in various types. The standard unit used to express atmospheric pressure is the millibar, written as MB. At sea level, normal atmospheric pressure is around 1013 millibars. If it drops below 1000 millibars, it signals a depression is forming. What is the meaning of acclimatize? To acclimatize means to help your body gradually get used to a new climate or environmental condition. When people travel to regions located at high altitudes, they are often advised to take breaks along the way. These pauses allow their bodies to slowly adjust to the reduced oxygen levels and lower air pressure. Take, For example, our armed forces, who are stationed in extremely high-altitude areas like Khardungla in Ladakh, which stands more than 5,600 meters above sea level. It's truly difficult to imagine life and work in such challenging conditions where oxygen is scarce and the atmospheric pressure is usually around 650 millibars, significantly lower than the standard pressure at sea level. Let's now move on to the fourth component of weather and study its instruments. D. Wind. Wind refers to the movement of air from a region of high pressure to one of low pressure. When we talk about wind, two major aspects come into play: its speed and direction. Wind plays a crucial role in defining the weather. Understanding how it flows helps in forecasting weather conditions. It is also essential information for pilots and sailors, since wind can greatly affect how aircraft fly and how ships move. Farmers, too, pay close attention to wind patterns as it helps them guess the direction from which rain clouds might arrive. Additionally, stronger winds mean the soil loses moisture faster. So, how do we figure out wind, speed and direction? A wind vane, also called a weather vane, is one common tool. It has a rotating arm, a pointer on one side and a tail on the other. When the wind blows, the tail catches it and causes the pointer to turn towards the direction the wind is coming from. It's sensitive enough to move even with a gentle breeze. A special type of wind vane seen at airports is known as a wind sock. Positioned on the tarmac, it helps pilots gauge wind direction during takeoff and landing. You'll also find wind socks in factories that emit gases or ash to observe wind flow for safety. To measure wind speed, the simplest instrument is an anemometer. This device usually has 3 or 4 small metal cups attached to a vertical rod. As the wind blows, these cups spin, and the faster the wind, the quicker they rotate. A small meter at the base keeps track of the rotations over a set time and calculates the wind speed in kilometers per hour. Let's now move on to the fifth component of weather and study its instruments. E. Humidity. Humidity is the final weather element on our list. It describes the amount of water vapor present in the atmosphere. Several factors influence humidity, such as temperature, wind, air pressure, and geographical location. For instance, between Kochi and Jaipur, where do you think humidity levels would be higher? Kochi, being close to the sea, generally has more moisture in the air than the drier inland city of Jaipur. But how do we actually determine this? Here's something to remember. When evaporation takes place, it leads to a cooling effect. However, if the air is already heavy with water vapor, that is, if the humidity is high, evaporation happens more slowly. That's why a rainy day often feels damp and sticky. Humidity is usually measured as relative humidity. Air with zero moisture, a condition that doesn't naturally occur, is marked at 0%, while air completely saturated with water vapor is said to have 100% humidity. Typically, dry conditions range from 20% to 40%, whereas humid conditions usually lie between 60% and 80%. The tool used to measure humidity is the hygrometer. Like thermometers or barometers, various types of hygrometers exist, each operating on different principles. Monitoring humidity is essential in many fields. For example, in food processing, controlling moisture is crucial. Museums, too, keep an eye on humidity levels since a dry atmosphere is key to preserving delicate exhibits. What are weather stations? As you've learned, tracking the weather involves the use of several different instruments, each one measuring a specific aspect like temperature, wind, humidity, or rainfall. A weather station brings all these tools together in one place, allowing for systematic and convenient observation of weather conditions. Readings are taken at regular intervals, which helps experts map weather patterns and make accurate forecasts. An automated weather station. An automated weather station, AWS, is a modern, self-functioning setup equipped with multiple sensors. These sensors monitor and record data such as temperature, humidity, wind, speed and direction, precipitation, and atmospheric pressure. Because it runs without human assistance, an AWS is especially valuable in remote or high-risk locations. These stations play an important role in fields like agriculture, aviation, navigation, and environmental research, where real-time and precise weather data is critical for decision-making. In 2023, for example, the National Disaster Management Authority installed an AWS at a glacial lake in Sikkim, situated at more than 4,800 meters above sea level. This station provides early warnings about changing weather conditions, crucial in such fragile and high-altitude environments. Predicting the weather. Meteorologists gather weather-related data using various instruments over extended periods. By analyzing this information and applying scientific methods, they aim to forecast weather patterns. These forecasts are becoming increasingly important, especially as climate change contributes to the growing occurrence of extreme weather events like cyclones, floods, and droughts. Having accurate weather predictions allows people and authorities to be better prepared. For instance, local administrations can organize emergency supplies and evacuate at-risk areas ahead of time. If rough seas or a cyclone are predicted, fisherfolk are alerted to avoid setting out, and entire coastal regions might be temporarily evacuated to prevent loss of life. Remember, temperature, humidity, rainfall, precipitation, wind, and atmospheric pressure together make up the weather conditions of a location. Each of these elements is measured with the help of specific instruments. The data recorded helps scientists track current weather and forecast future conditions. If you found this video useful, feel free to click the like button and subscribe to our channel. At Minecraft, you can expect to see a whole lot of videos that will help you prepare for your exams smarter, faster, and better. See you soon.